Hello everyone, welcome to UCL Creativity in Technology webinar series. This is our third webinar and we have Dr. Zhou here to talk about his research and his perspective in viewing creativity. If you have any question, please leave it in Q&A box. We will discuss some of them during this talk. If your questions cannot be answered in this live, please feel free to email Dr. Zhou. So Dr. Zhou is doing his research in 3 departments in UCL: Department for Medical Image Computing, Department for Computer Science, and Department of Pharmaceutics. He has general interest in electrohydrodynamics and polymer materials. Dr. Zhou's presentation today will deal with EHD forming of biomimetic polymer materials and their applications in medical imaging and tissue engineering. After his talk, Dr. Zhou and I will have a discussion in terms of how creativity affects his research process in the discussion, and we will also discuss 1 or 2 of your questions. Now let's welcome Dr. Zhou.
Good afternoon, everyone. My name, thank you very much, Noya, for the introduction. My name is Fenglei Zhou. I'm a senior research fellow working across 2 departments, computer science and pharmaceuticals at UCL. I'm very pleased to give a talk today. First, I would like to thank Noya Tan for the invitation. So in today's talk, we talked about some novel polymer materials generated by the technology of electrohydrodynamics, and also their potential applications for COVID-19. First, I will briefly introduce my educational background and research experience. Then I move to the technology of electrohydrodynamic forming and polymer materials. Finally, I will present the potential applications of EHD-enabled polymer materials in COVID-19, with a focus on electrospun nanofiber face masks. I came to the UK more than 10 years ago in 2006 for my PhD study in school materials at the University of Manchester. After I got my bachelor and master degrees from Qingdao University, which is sitting in the northeast and east coast of China, very beautiful seaside city. After I got my PhD, I joined the School for Medical Science, the same university, to pursue my research career. In last summer, I joined the UCL to continue my research. In the past 10 years, my research has been mainly focused on developing polymer nanomaterials with novel function and novel structures from nature or synthetic materials by the technologies of electrospinning and electrospraying for a range of applications, including biomedical imaging, tissue engineering, smart wearables, and drug delivery. Now let's look at the technology first. Electrohydrodynamics, I will call EHD in all my following slides. It is an interdisciplinary science dealing with the interaction of fluid and electro field. EHD forming is a very advanced manufacturing technique capable of transforming polymer solutions or polymer melt into nanofibres or nanoparticles through a very strong electro field. EHD forming is often presented in 2 forms, as presented on top left images. The first one is electrospraying, and second is electrospinning. Electrospinning is a process describing the formation of nanoparticles, as shown here. And in contrast, the process of electrospinning is a continuous fiber forming process. These 2 processes, electrospinning and electrospraying, share the same mechanism, both use the electrostatic field to disperse the polymer droplet into nanofibers. But the resulting fibers, as shown here, they are completely different. And it's very interesting. These two processes is convertible by tuning solution properties and solution properties. At the boundary of electrospinning and electrospring, we can expect this beaded composite structures of nanofibers and nanofibers and particles. In the process of electrospring of nanoparticles, both solution properties and also process parameters could affect the final morphology and size of these particles. It could be hollow or solid particles, or core-shaped structure of multi-layered particles, or it could be spherical or shell-shaped. More interestingly, these nanoparticles would be used to encapsulate, different bioactive agent for a range of applications, from drug delivery and therapeutics, or functional coating for the implant stands, as well as a tissue scaffold for tissue repair or regeneration. In the case of electrospun nanofibers, they have even wider applications, ranging from tissue engineering scaffolds, filtrations, nanocomposite, smart sensors protecting clothing, and skin masks and drug delivery, and as well as wound dressing. As we all know that what is happening since the end of last year, the coronavirus has produced a profound and comprehensive impact on our life and work. Unfortunately, has resulted in 100 million deaths globally. In the materials community, there have been tremendous efforts and extensive studies on seeking effective solutions for the challenges raised by the COVID-19. So what are these efforts and studies? In other words, how materials scientists could contribute the combat against this new coronavirus. Firstly, the high-resolution imaging tools which commonly used for materials can be used, such as transmission electron microscope, TEM, can be used to determine the structure of the virus, which obviously will help benefit the development of new vaccines and therapeutics. Secondly, some biopolymers that are already used in antiviral drugs can be reused, reformulated with new molecules, for example, to develop new antiviral drugs especially for the coronavirus treatment. Thirdly, the fluorescence detection-based point-of-care devices, which is similar to the pregnancy test device, could be used for the early detection of coronavirus, which could reduce our heavy dependence on the PCR, which requires controlled temperature and also quite expensive. Finally, wearing face masks has been proved very effective to reduce the coronavirus transmission, especially wearing high performance face masks made from nanofibers. So in the next few slides, we will have a look at these face masks. In 1 week time, basically next Friday, we know that we will have to wear face masks when we go out for shopping. And Public Health England has published our guidance when to use surgical face masks and FP3 face FP3 respirators. And some of my friends, colleagues, and relatives, they do know the differences of between these two face masks, but there are many more who don't know the differences. So here, let's look at the influenza masks first, which you probably have heard of this influenza pandemic happening in 1980. That's obviously the scale, the impact, and the nature back then was different from today's pandemic, but the act of wearing face masks is widely adopted, similar to what we are doing right now. At that time, the face masks provide provided certain level of protection against influenza virus infection. But we have to know that at that time, there were no professional face masks as we have today. So owing to the advance and development of polymer science and novel technologies, now we have more and better options, including surgical face masks and FFP3 respirators. So for surgical face mask, it is basically a 3-layer sandwich structure, no woven fabric. Top and the bottom layer is shown here. The sperm bonded polypropylene fiber mesh, and the middle layer, the middle layer is a multiple PP fiber mesh. Sperm bond and multiple, there are two terminologies, two processes in novel industry used to generate different type of fibers. As shown by the SEM image here, you can see the fibers in the middle layer much thinner than those fibers present in the top and bottom layers. It is very easy to understand. So it is the middle layer that determines the future efficiency. But because the fiber is tiny, it has very weak. So therefore, we need some, we need the top and bottom layers with thick fibers to act as a support, hold them in place to get the structure integrated. It can be envisaged that by increasing the number of layers of these fabrics, we can achieve high future efficiency. That is exactly how FFP3 respirator works. This is an example of FFP3 respirator shown here. So FFP3 is as shown in this table. Is basically a respirator standard. So from this standard, we got to know this. So the future has this face mask has a future capacity to remove at least 99% of all the particles having diameter larger than 300 nanometers. And as you can see, there are other type of respirators having high or low filter capacities. Obviously, in general, if the high number represents high filter capacities, obviously it will be more expensive. Currently, there are two types of common face masks are being used to reduce the coronavirus transmission: surgical face mask and N95 or P2. So due to the time limit, we don't talk about too much about the mechanism. But for face masks in use, there are up to 4 mechanisms as listed here in watch to prevent these particles with variable size to penetrate into to reach the particle, to reach the face mask wearers. And these particles can be divided into 3 groups based on their diameters, as shown here: micro size and micro size and nanometer size. As I said, due to time limit, we probably just have a quick look at this nano-sized group, because coronavirus belong to this group. It can be imagined, so such small particles can easily pass through the micro-sized pores present in these 2 types of face masks. That is why people say it can reduce, but cannot provide 100% guarantee protection by these 2 types of face masks. So in order to capture the coronavirus or nano-sized particles, the diffusion mechanism has to be followed, which can only be achieved by in the nanofiber-based face masks. At the moment on the market, there are some commercial nanofiber face masks available, and most of the nanofibers are generated by the technology of electrospinning, which I mentioned previously. And the concept of designing nanofiber face masks is similar to the surgical face masks. And in that is to say, as shown here, a layer of nanofibers is used to replace the multiple macro-size fibers layer, which helps achieve much higher field intensity while keeping good high comfortability and good pressability. There are many more nanofiber-based face masks are being developed at the moment. So a few examples are given here. The first example is face masks with oxygen supply, and the second is transparent face masks, which you can basically see your whole face. And the third one is washable, reusable face masks. Hopefully, in the near future, all this type of new nanofiber face mask will be available. But also, so these nanofiber-based face masks could cause some environmental issues, considering the amount of the face masks to be consumed by the millions, hundreds of millions of people globally. So we have to think ahead and take actions to minimize or avoid any potential pollutions. We have to learn a lesson from the macro plastics. And for example, can use these face masks as many times as it is safe, and can we recycle them? Can we make these face masks from renewable materials, and so on. Another issue is, as we all know, that at the moment there are no effective vaccines or therapeutics, especially for coronavirus prevention or treatment. The top obviously it is a top priority to get this vaccine or therapeutics, considering the scale and impact caused by COVID-19. Nanomaterials can play a key role by providing effective and safe vehicles to deliver these therapeutics or vaccines being developed to the vulnerable people or patient. So these kind of the drug or vaccine encapsulated nanomaterials are considered as a nanomedicine. Actually, EHD forming has been widely explored to produce polymer-based nanomedicine. For example, electrospinning, after a mineral modification or its spin rate, can be used to generate hollow nanofibers. This kind of structure are very useful in terms of encapsulating the therapeutic molecules, and also they can be responsive to external stimulus such as pH, temperature, and heat, magnetic field, and the light to make them to make this kind of encapsulated molecules released and control. So similarly, and for electrospraying, it can be also used to generate hollow nanoparticles or spheres, which can be used to encapsulate different therapeutics or vaccines for controlled release. At the moment, the research in these areas, there hasn't been too much research in these areas, but I'm sure in the near future, more studies and publications will come out. So hopefully through this talk, you get some useful information, which is summarized here. So the HD forming is a very versatile technique which can be used to generate nanofibers and nanoparticles from different polymers. And the electrospun nanofibers have been used to develop the high-performance COVID-19 face masks. And in the near future, hopefully the hollow nanofibers and nanoparticles enabled by the co-HD will be used to develop smart nanomedicines. Last but not least, I would like to thank you all for the listening.
Thank you, Dr. Zhou. So I received some questions for your presentation. I think so. As a layman, actually, I don't really know too much about medical science and this material science things. But I found it's really like understandable for me, at least as a psychology student. And even though I don't have too much time to ask some specific questions in your research, but I do want to ask like a common question that our live audience are interested is how long it will take before a newly developed material be manufactured and be available to the public. So because you mentioned near future, so is there like maybe any prediction for that, or you think it's difficult to say?
Yeah, at the moment, probably from the news, as the BBC reported, vaccines, many countries around the world, in the US, in the UK, and in China, some of the vaccines already, go into the clinical trials. Some are already in the phase 3. So, it is some expert expected probably, end of the year or early next year, we could get some vaccines, for this COVID-19.
And how about this mask, the newly mask?
The face mask at the moment, if you just do a Google search, there are many, electrospinning companies who claim to generate a nanofiber face mask. But as I said, most of them, they basically use the same, concept like the surgical face mask. You just use 1 layer nanofibers between, the spun-bonded macroside fibers. Yeah, they are commercial. They are not. Just put one example there. At the moment, there are different type of face masks already available on the market. Yeah.
Right, thank you. So we can basically, there are more advanced technology in face mask already, and we can already like buy them online. Is that?
Yeah. Yeah.
Thank you. And also, I'm just wondering, so in this kind of extreme intense situation in this pandemic, do you think it's a good thing for your creativity and your innovation? Or do you think, so basically, do you think you're more creative in pandemic or in normal condition? Because this is kind of new thing, right? So
Yeah, obviously it's coronavirus. It's a bit new. It's a new issue, new problem, and new challenge, and facing humankind. As a researcher, I think, yeah, you gotta, thinking about, your research, especially like, how to transfer, in labs, you probably you gotta something, already got something, for example, which initially used design for something else. You could think about whether, you can easily adopt, your materials or your product to be used, especially for COVID-19. For example, in our own lab, nanomedicine lab, we already got a lot of expertise developing the nanofibers from different materials and functional with different functions. So we got at the moment we got ideas to generate some face mask with face masks, not simple function some therapeutic functionalized nanoparticles. On the one hand, it can filter it can filter this virus out. On the other hand, once this the face mask is contaminated by the virus because this face mask is functional with some medicine. It could we hope it can can kill this virus as well. So that's one of the idea we developed during the lockdown period. Yeah, we at the moment we have conducted some feasibility study.
thank you. That's very clear, I think. And also I have two more questions. One is about creativity, and one is about your research. So the first one is really like fit our topic. So how do you define creativity in engineering? Because we don't even have a very common definition for creativity. Like, don't even say in engineering field. So do you have any idea about this?
I think it's a very broad question, to be honest. From my experience, creativity is basically a fundamental element for engineering. So it's concerned with basically the generation of novel and effective method to problem. Yeah. But in terms of how to define the creativity, I think for engineer, to be creative, I think there are a few key characters. You have to be very knowledgeable. You have to be, have this, you have you get expertise. Know the physics or chemistry or the materials behind the problem, and you have to be practical. You have the hands-on experience. You have to test, the concept, your ideas. And thirdly, you have to be very open-minded. You are, you can accept, you can accept basically the ideas, opinions from different people, And finally, I think it is a very collaboration very important, especially the collaboration with the people from with different background from you. That's also very important. Yeah, that's my opinion.
Yeah, so basically it's the first knowledge and also the skill to like the hand-on things, and also the open-minded and the the teamwork can work, not just work with the people who are in your field, and also work with people who are like
exactly.
not in your field. And that's also like boost your open mind, right? If you talk to people like who are having the different logic, so study and exploring logic. Okay, I have one more question. So basically we have an audience who is asking, are you affiliated or interested in the intersections of your research and biodesign, or the adoption of biology into the manufacturing process of novel materials?
I think I'll be interested in both, to be honest.
So can you like talk about it like a little bit more, like a little bit more specific? So what's the potential direction or something?
Yeah. First of all, as you can see from my slides, I was trained in basically in textiles, more especially in textile materials. But after my PhD, I joined school medicine in a biomedical imaging group, which I'm the only one has a materials background. At the beginning, I was really concerned whether what I can do and what I can achieve. But after this, after a few years, I'm still working on basically same group. So yeah, after a few years, I gradually realized that yes. So by working with the researchers, the colleagues with different background, I learned a lot from them, and I know. So I got to know what is the problem they are facing, for example, in the biomedical imaging areas. So they want to design something which could help, something they want to basically engineer something, a specific, materials, for example, test object, which they don't know whether they can do it or not. That's why they are interested in my background and they hire me to give it a try. But on the other hand, I think from my personally, I learned a lot about the medical imaging, and I mean for example the MRI, what is how it works and how it is used for preclinical and clinical, preclinical and clinical context. Now I already know. So based on this experience, I already now developed a relatively new research area. New biomedical, I call biomedical tissue mimicking materials, especially for validation of magnetic resonance imaging. This is a very new area and helps me a lot to attract research fundings, help me publish papers. Yeah, I think it's very difficult to distinguish sometimes. But in general, I would say I encourage people to conduct the multidisciplinary research if you want to do something quite exciting. Yeah.
So I think like you also agree that your interdisciplinary research experience like boosts your creativity somehow, right?
Yeah.
Yeah, me too. Like I'm also interdisciplinary research student, so I feel the same. Like once you get like enough knowledge in both areas, I think, because I found that for people from different fields, they have totally different logics. That's the most like difficult part. Like I feel like it may like encountered.
Yeah, and also one slide I didn't include in my talk because the time is worried about the time. So I'm talking about the face masks from the engine, from the materials point of view, from the from nano technology point of view. These are just in last month. These are very good comprehensive study was published, a paper published by Oxford, a professor at Oxford. So they look at it as the role of face masks from the sociological point of view. That's yeah. If some if you're interested, I can send to you people. You can look. I learn a lot. Yeah. Yeah.
Yes, please. Yes, maybe like please, could you please send me the link, and when I send the recording version to all the participants, then like they will just see the link.
Yeah, definitely. I can say yeah. Then share this with you. Yes.
Thank you very much for today's
My
talk.
pleasure.
It's very inspiring for me, and I think it fits current situation very well. I think, and people might be learn from that, like how to increase our creativity. For now, it's a negative thing, but we should use it. We should accommodate ourselves in this kind of situation and make our future life better. I think that's the thing
I
that.
totally agree. I totally agree. Yeah, I totally agree. Yeah.
Thank you very much, Dr. Zhou.
It's my pleasure.
Bye everyone.
Bye bye.